The lecture is of the contact forces and the force equations. Okay. So what we will do is first we'll try to understand how to write the force equation. Okay. So we'll learn how to basically write the force equation and then we'll move ahead. Are you able to get me or not? So I'll ask, like, we'll start with some basic things and then we'll move to the understanding of contact forces. Okay. So I'll do one thing. Let's suppose I'll ask you some things, then I'll make you understand. Okay, so let's suppose there is a block. ठीक है, एक ब्लॉक मान लो जिसकी मास कितनी है m, और इसके ऊपर मान लो मैंने एक फोर्स लगाया, ठीक, and that force is making some kind of angle theta with respect to the uh, horizontal. Okay, yeah, horizontal whatsoever. Okay, and so this is force F which is acting on this body. I want you to write the force equation of it. Force equation, or many people call it as equation of motion. ठीक है, हाँ, तो इसको कैसे लिखेंगे अगर हमें लिखना है तो सबसे पहले रिजॉल्व करना है, तो रिजॉल्व कैसे करेंगे हमें मालूम है। अगर सर एक ट्रायंगल दे दी जाए, I'll go through the scratch of a little bit. I'll scratch the bones, then I'll move ahead. So this is theta, this is base, this is, sorry, opposite of theta is perpendicular. This is base and this is hypotenuse. So we know that we can write P is equal to what? H sine theta, and base is equal to H cos theta. That's all, isn't it? So another way of treating the fact is like if I say, if you have these kind of axes, okay, and then on this, let's suppose there is another vector which is drawn over here, and if this vector A is making some angle theta with the horizontal or any attached side, then this A with respect to theta is nothing but modulus of vector A into cos theta, and the opposite side will be modulus of vector A into sin theta. Are you able to get me or not? I'll not go into the depth of that. Why I wrote modulus. Okay, simple सी बात है, vector A की जो ये जो length है, basically this length will be represented by modulus of vector A. Are you able to get me or not? Yes. So look over here. If I look into this force thing, then this force has two components, one along the horizontal, one along the vertical. Are you able to get me or not? So the horizontal will be F cos theta because that is working like a hypotenuse, and the perpendicular will be how much? F sine theta. Are you able to get me or not? Now, if this mass, if I apply this mass will accelerate if the surface is smooth, isn't it? So what is the equation? Basically, how to write the equation? You have to think of the Newton's law. Then you have to imagine which force is accelerating, right or not. So if I look into this mass F, is F sine theta is going to accelerate? No. But which force is going to accelerate? F cos theta. So the equation you will have to write that F force which is accelerating in nature minus force which is reposing in nature, reposing that acceleration, okay? That should be exactly equal to mass into acceleration A. Are you able to get me or not? So force, which force is accelerating? F cos theta. There is no reposing force. So F cos theta is exactly equal to m, and this is going to be called as equation of motion. Are you able to get me or not? मेरी बात समझ में आ रही है ना? How come you can say like that? But that force, I'll come on that. I'll come on that. Wait. Okay. So basically, F cos theta is equal to how much? Ma. Next thing is, let's suppose if there would have been some reposing force. Let's suppose there would have been some another force in the horizontal direction which is reposing. But this force F is basically less than F cos theta. Okay. So the body will still accelerate towards right or not? So then the equation for this kind of thing, the equation will become F cos theta minus F is equal to mass into acceleration. Are you able to get me or not? Understood. Now, Considering of vertical, I'll come on that, how to write the verticals. But before that, we need to understand about what is going to be called as contact forces and all. Okay. Okay, is that clear? So, write one question, do it. बोल रहा है कि if there is a surface, a minute, let me draw it over here. And then I place a block of mass M, which is of mass 5 kg. Okay. I apply a force which is 50 newtons acting at an angle of 37 degree. At what angles it is acting? Yes. The question is, if there is an reposing force of 10 Newton, then find the velocity of block after 2 seconds. Okay. If this motion starts at exact t is equal to 0, where velocity of the block is 0. Do it. Two minutes from now on. बोलो कितना होगा? 12. लेट मी चेक. अच्छा देखो ध्यान से बनाते हैं, ध्यान से देखो. तो बेसिकली दिस इज going to be 50 cos 37, isn't it? Are you able to get me or not? Now if I look into cos 37, how you have to remember, do you know that trick or not? Yes, so if this is 37, then opposite side is 3, then this is 4, this is 5. So cos 37 will be 4 by 5, isn't it? So that means that this force along the horizontal direction, if I look into this block of mass 5 kg, then horizontal force towards this is around 40 newtons. Are you able to get me or not? From this side it is how much? 10 newtons. So equation will be what? 40 minus 10 is equal to mass 5 into its acceleration. So acceleration will be how much? 30 by 5, which is how much? 6 meter per second square. Now, you know that to find in terms of like I was required to find velocity. So the direct relation of the velocity will come from acceleration. So how? Because I can apply v is equal to u plus at. So initial velocity was 0, acceleration is 6 into time 2. So this is how much? 12 meter. Correct. Is this clear or not? So basically, out of these, there were things which were getting solved easily, but we'll start with some of the things, and that thing is, let us go into dig deep into this. And to dig deep into this, one of the most important thing is we have to understand about this particular kind of force, which we call it as contact force. Okay. Now the question arises that what is contact force? That's the biggest thing, isn't it? So to understand basically about that, let us understand two things. How the bodies are going to be in contact. Let's suppose if I take block A and then I take block B and I place it on top of each other. So it's visible that the surface between them is a kind of planar kind of thing, isn't it? But in actual case, the surfaces are like this way. Basically, the surfaces of A and B are not plane, although they can be how much smooth they can be. Okay. And in B, taking those vacant space. Are you able to get me or not? So this is how A and B are placed. Are you able to get me or not? Now, they are being silent on each other. You look over here. So basically, the block A is trying to press the block B or not by some kind of force. Are you able to get me? Now, for that force, you know that as the block B is rigid in nature, which kind of nature? Rigid. It will try to apply some same kind of reaction on the top of this block A or not. Yes. So you know that means whenever there is a force, there is an equal and opposite reaction according to Newton's third law, isn't it? So Newton's third law says that if I apply a force, then for that I will have an equal and opposite reaction. And this is what is happening when block A is trying to press my block B. Block B is providing a reaction which is exactly equal to the, let's suppose if A would have been applying some force F, the block B will also apply the same force such that these two bodies should remain in which kind of a state? Equilibrium state or rest. Are you able to get me or not? Is this clear or not? And this appearance of two equal and opposite forces which are coming over here due to the means these forces are only appeared when B is placed on top of means when A is placed on top of B or not. Are you able to get me? If I would have not placed it, then this forces F and F would have not been appeared, isn't it? So that is why when we brought the two bodies together, that means when we are trying to make a contact of two bodies together, there is an appearance of equal and opposite force between the surfaces or not. And these equal and opposite forces are called as contact forces. क्या बोलते हैं इसे अपन? So what are contact forces? Nothing but two, basically a pair of forces appearing on two bodies together at the same instant of time. Are you able to get me or not? Is this clear or not? So means now the question arises that does this contact forces will have many more types, or does this does this is what is going to happen? मतलब कुछ भी हो सकता है, ठीक है? Are you able to get me or not? So the basic concept is like how to understand what are kind of different kind of contact forces. We got to know these are the forces which will appear between two different bodies when they are going to make contact with each other. Are you able to get me or not? Yes. So let us understand what can be the types of forces. So basically, I'll give an example to you. So let's suppose if there is a hanky in your hand. Okay, let's suppose there is a hanky. Means hanky देखे हो ना मतलब ऐसे वो सबके पास रहता है ना? तो अगर मैं इसके ऊपर एक एक बॉल को रख दिया, क्या रख दिया? बॉल उठा के इसके बीच में रख दी, तो क्या ये हैंकी नीचे से ऐसे बेंड होगा या नहीं होगा? ऐसे बेंड हो जाएगा ना? क्रीजेस रहेगा वो कुछ इस तरह से ऐसे 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 बेंड होने की कोशिश करेगा या नहीं करेगा? Are you able to get me? Isn't it? So this hanky will make the surface to go down. Are you able to get me? Now you can even understand. Let us suppose that you do one thing. You stand on a muddy ground. Okay, when you have a ground which is muddy in nature. Yes. So when you stand over there, when a person stands on those muddy ground, what does he feels? That the surface goes beneath him or her or not. But when you are a rigid object, what do you feel? What happens when there is a rigid surface? What does it feel? Does that particular body is able to pierce that surface? No. It is still standing still over there or not. So this is the meaning that as I know that as the block will try to press, how it will press by its weight, which we call it as mass into gravity. So you are able to get me or not? So this body M is trying to press the surface by its own weight. How much? Mg. Now you know that for this Mg there must be an equal and opposite reaction. Yes. So basically the ground applies an equal and opposite reaction exactly at the center of the body where the whole mass is felt to be concentrated. Are you able to get me on? And that reaction provided by the rigid surface we call it as normal. क्या बोलते हैं इसे अपन? Normal. Are you able to get me or not? So basically, this normal is basically you can see over here. This normal is not like some another similar kind of gravitational force. It's a reaction which is appearing due to that mg or not. Are you able to get me or not? And that is why look over there. This pair of forces. Now, as you know, that normal is present over here. That is a reaction. We call this normal as contact force because it is only appearing when the body is kept on the ground. Are you able to get me or not? Understood? Yes. So what is a normal? Normal is a contact force which is provided by the rigid body when two bodies are coming in contact with each other. Are you able to get me or not? So that means if it is a normal, when there will be two bodies in surface. See, if this is the ground, then it's okay. But let's suppose if the two bodies are made to be in contact like this way. ठीक लेट सपोज ऐसे दो ब्लॉक्स को रख दिया आमने सामने एक दूसरे के ऊपर आर एबल टू गेट मी और नॉट ए एंड बी एंड इसके ऊपर एक फोर्स लगाया वंस अगेन ब्लॉक ए विल ट्राई टू particularly push my block B or not. So block A, by what force it will try to push? Since there is no external force present over here, this block A will try to apply a contact force, isn't it? So then that contact force is going to be called as normal. Are you able to get me? Now as block B will also try to repose this force or not? According to Newton's third law. So then once again a contact force appears which we call it as normal. Are you able to get me or not? Understood perfectly. So once again here also for this normal there is an presence of an external also other normal on the ground, but as the ground is so big this normal is just getting absorbed. Are you able to get me or not? See, the ground is very big or not? So when you punch a wall, does anything happens to the wall? Does the momentum changes of the wall? No. So what happens? Basically it absorbs all the forces, then only the net momentum becomes zero or not? Absorbs means it gets spreaded out over there in all possible directions. Are you able to get me? Are you able to get me? Means that makes the whole normal at a point to be very less. Is this clear or not? Understood? So basically we'll define our normal. I'll define our normal thing. What is normal? Normal is nothing but a kind of contact, isn't it? And which kind of contact force appears when two bodies comes in contact? Appears when which kind of two bodies? Two rigid body comes in contact. comes in contact with each other. Are you able to get me or not? So basically, all these forces, I'll tell you. So I'll tell you in beforehand only. The contact forces are divided into four categories. How many categories? Four. Okay. I'll show you which are those. Okay. The first one is, এই তুমি খুব ভালো বাংলা বুঝতে পারছি না? You do understand? আমিও খুব ভালো ওকে সো আমিও খুব ভালো বাংলা বুঝতে পারছি or I can even speak word or not. Yes. Okay. So let's suppose if I select contact forces. So there are five different kinds of contact force. First one is normal. Second one is tension. Tension force is also a kind of contact force. Third one is spring. In many books it does not say spring, but as the nature of a spring force is there, it can be termed as a contact force. And fourth one is frictional force. Are you able to get me or not? So out of all these, oh, sorry. So basically there are four kinds of contact forces. Out of these, top three follows one single property. Okay, but the friction has a little bit of exception cases, and we will discuss about that. Are you able to get me or not? What is that one single property which is common in all these? That they will create a pair of forces. क्या create करेंगे? Basically we got to know na, how what was contact forces. It is a pair of forces appearing on two blocks, two bodies together at the same instant of time or not. So here also all these forces will create a pair of forces. Friction will even create, spring will even create, tension will even create, and normal will also create. And those pair of forces will provide the understanding of contact forces. Now the condition is that these pair of forces are equal in magnitude but opposite in direction. कैसे होते हैं? Equal in magnitude but opposite. Are you able to get me or not? मजा आ रहा है? फील आ रहा है? Is this clear? Yes. So we'll see how. Then we define our normal. Normal is a contact forces appears when two rigid body comes on contact with each other. That means there will be a pair of normal for each and every contact. For each and every contact. Remember that the normal acts from the center of mass. Actually, it acts from center of mass, but for our convenience, we will select to be working on the sides or at the contact. Okay. Yes. We select that it is present on the point of contact. Are you able to get me or not? Is this clear? Now, if the surface is a linear surface, then the drawing of normal is very, very good. You can take two blocks. The perpendicular direction will provide us the normal. But if there is a curvical surface, which kind of surface? Then let's suppose if a body is making a contact surface over here, then how to draw the normal? First, select just see the contact surface. Then along that contact surface, draw a tangent and draw a perpendicular on that. This will give me the direction of normal. Are you able to get me or not? Is this clear? Understood? So should we know how to draw some of the basic normals cases? Yes. So look over here. Let's suppose. Hmm, now let us take first case. ओके तो पहले ये बात नॉर्मल समझ में आई या नहीं? नॉर्मल है क्या? किस तरह का फोर्स है? कॉन्टैक्ट फोर्स. फोर्सेस। ये बेसिकली में एक रिएक्शन है, ये क्या है, एक रिएक्शन, सिंपल सी भाषा में। हाँ, जैसे हाथ पे अगर मैं एक ईटा रख दूं तो हाथ क्या फील होता है, हैवी फील होता है या नहीं होता, but still my hand is stopping that block or not. So that block is trying to pierce that hand, but since it is piercing it, there is an equal and opposite reaction from your hand. That opposite reaction is going to be told as normal. Are you able to get me or not? So remember that normal is a contact force, but this mg is a gravitational force. Are you able to get me or not? Is this clear? So this basically due to the balance of forces, n is equal to mc. But these are two different kind of forces. Are you able to get me or not? So you will not treat mg as normal and normal as mc. Okay, understood? Can I move ahead? So look over here. Let's suppose you will do the first case. Let's suppose there are two blocks placed on top of each other. Okay, block A, and then there is block B. Got it or not? I place it on top of each other. This is mass m1 and this is mass m2. Draw all the forces for this combination of system. Draw it fast. In both the cases, you'll have to draw all the forces. Did it? Drawn it? Okay, 1 minute. So now look over here how to draw it. Basically simple. So I'll tell you one trick to draw. Although you might be drawing, but see this. Just do one thing. Just lift up these blocks a little bit away from each other. Okay. Whatever is given to you, just lift them up. Okay. Give them some space. Correct. So this is my m1. This is my m2, isn't it? So the now draw the gravitational forces. M2g will work over here, isn't it? And here, from here, what will work? M1g. Are you able to get me or not? Now, for this, now start from the topmost position. You know that due to M1g, there will be a reaction on M1, isn't it? So, from the M2 surface, I brought this and I call this as normal N1. You know that for each and every normal, there is an equal and opposite reaction or not. So, N1 will be also present over here. Are you able to get me? On the from the surface, there will be another N2 which will be present. Now on the ground also there is another N2 present, but that is getting absorbed over here also or not. Are you able to get me? So if the bodies are in equilibrium, if I look at mass M1, since this mass M1 is at equilibrium, the upper force balances with the downward force or not. So N1 is equal to how much? And N2 is equal to how much? This is down also, this is down also. So N2 plus M2. Sorry. Yeah. So this becomes how much? M1 plus M2 into gravity G. Are you able to get me or not? Similarly, let us take one more case. 1, 2, 3. Okay. One block, then two block, and then three blocks. Right or not? All surfaces are smooth. M1, M2, M3. Draw the contact forces. Draw all the forces basically. Just draw it fast. Draw it. Should I move ahead? Okay, now look over here. If I once again if I separate all this system, what I will be looking at one, then the second block M3, then the second block M2, isn't it? And then the third block M1. Are you able to get me or not? So these are my three blocks M1, M2, and M3. Now, once again, I'll start from topmost position, isn't it? So I'll start with it M1G. For that, N1, and then equal and opposite N1 over on M2, isn't it? Then once again, M2G from M3, another normal N2, for that equal and opposite N2, M3Z, and topmost N3. Are you able to get me or not? So I will draw N3 on that. Is that clear? So basically N1 is equal to how much? M1G once again. N2 is equal to M1 plus M2G, and N3 is equal to M1 plus M2 plus M3 into gravity G. This is going to be my equation or not? Are you going to understand me? ठीक. So basically these are some of the basic understanding. I'll give you one more case. Let us suppose I take two walls and then I place on it a ladder. What I placed it? ठीक. मान लो इस तरह से लैडर मैंने एक बना दिया. अब पूछा कि ड्रॉ द नॉर्मल फोर्सेस एंड द पर्टिकुलर वेट. ड्रॉ ऑल द फोर्सेस बोल दिए. यस, ड्रॉ ऑल द फोर्सेस. डू इट फास्ट. ड्रॉ ऑल द फोर्सेस. कैन यू डू इट? अब ध्यान से देखो. तो बेसिकली अगर मैं ध्यान से दूं तो यहाँ पे कांटेक्ट फोर्सेस कितने हैं? दो. एक ये और ये कौन सा? एक ये नीचे वाला. हाँ. तो इसके लिए क्या हो जाएगा? तो इन दोनों कांटेक्ट फोर्सेस के लिए अपन हाँ परपेंडिकुलर ड्रॉ करेंगे, है ना? तो इसके लिए कितने नॉर्मल्स? एक ये और ये कौन सा? दो. और यहाँ से एक इसका वेट भी तो काम करेगा ना सेंटर से, जिसकी वैल्यू कितनी होगी? mc. आर एबल टू गेट मी और नॉट? सिमिलरली इफ आई टेक टू डिफरेंट रेक्टेंगुलर वेजेस और इसके बीच में अपन एक स्फीयर लगा दिया, ठीक है? आर एबल टू गेट मी और नॉट? यस. So then the question is, draw the normal. Draw the normal. How many normals will be there? because this is my first point of contact, isn't it? And this is also my second point of contact. But the weight of block will still act from the center of the sphere or not? Yes, this will be how much? Mg. If the sphere has mass, how much? M. And first I'll draw the tangent on these two contact surfaces, isn't it? Are you able to get me? And on this also one contact, one particular tangent over here. Are you able to get me or not? Now, if these are my two tangents over here, then I'll draw the normal, isn't it? So this is going to be my first normal and this is going to be my second normal. This is n1 and this has value how much? N2. Are you able to get me or not? So basically for all these cases, these things what we are doing, they are called as free body diagram. इसी को बोलते हैं क्या? Basically what is free body diagram? Nothing but the representation of all the forces of the bodies. A representation of all the forces appearing on one body. Are you able to get me or not? Is that clear? Is this clear or not? So basically these are going to be called as your normals and all those kind of things, whichsoever you want to call it. And based upon that, we will have a things over there. Okay. ठीक. तो अपन इस चीज को समझने के लिए since we are trying to understand all of these things in a much more better sense now, as we know how to draw the particular normals, we will try to bring them these bodies in the motion also. Okay, so we'll see the motion through the normal forces. Are you able to get me? So let's suppose, let us consider the first case, one of the most astounding case. एक पहला केस कंसिडर करते हैं, ठीक है ना? मान लेते हैं एक सरफेस है जो कि स्मूथ इन नेचर है. कैसी है? अभी जितने सारे सर्फेसेस के बारे में हम बात करने वाले हैं, all these surfaces are basically smooth in nature. Are you able to get me or not? So consider a block 1, then in front of it I place another block, wide or not? Okay, this is my second block. Okay, so this is my M1 and this is my M2. Or do one thing, let me just bring it towards this side so that have a better, we can have a better understanding. ठीक. मान लो ये M2 हो गया और दूसरा हो गया M1. Are you able to get me or not? And I applied a force F over here. The question is, write the equation of motion. Okay, the question is simple. Write the equation of motion and write the equation of motion and the amount of contact force present between them. Present between the blocks. जल्दी से बताओ. 2 minutes you have. Okay. Tell me fast. What is going to be the equation of motion and जल्दी से बताओ होना क्या चाहिए. मतलब दो बॉडीज को अगर मैं कांटेक्ट में लेकर लगा देता हूँ और फोर्स लगा देता हूँ फिर दौड़ा देता हूँ तो बेटा इसके अंदर कितनी कांटेक्ट फोर्सेस होगी, क्या वैल्यू होगी कांटेक्ट फोर्स की, वो सारी चीजें बतानी. बोल हाँ यार, बता जल्दी से कितना होगा. ठीक है. इज दैट क्लियर? ठीक. Praveen, I will kill you. There are many guys who have joined live, you know. Okay, tell me, what can be the force? What can be the particular equation of motion over here? So, how to do it? See, 2 minutes are over. I'll kill you next time. So, stay word or not. You have only how many minutes? 2 minutes. Okay. So this is my M1. How to do the thing? Just do one thing, separate these blocks, okay? Every time, separate them, you'll get the clear idea. This is my mass M1, this is my mass M2. Are you able to get me or not? So this is my mass M1, this is my mass M2. I applied a force F over here, got it or not? Now, due to this force F, yeah. So this due to this force, yeah. So basically, this force will try to push this M2 by a normal N or not. Now there is an equal. Acha, okay. This is, oh shit. This is M2, this is M1. So on the M2 will try to push M1 or not. So let's suppose it pushes by normal N. So there is an equal and opposite reaction due to that N, isn't it? Now, as I apply the force, this both of the blocks will move with a common acceleration. Are you able to get me or not? तो ध्यान से देखो कि कॉमन एक्सेलरेशन क्या होगा. तो सर कॉमन एक्सेलरेशन तो हमें मालूम है कि जितना आपने फोर्स अप्लाई किया डिवाइड बाय टोटल मास ऑफ द सिस्टम विल प्रोवाइड मी द कॉमन एक्सेलरेशन. ये और yes. So basically, what these normals are doing, these normals are basically doing the same thing. They are providing. Basically, if I look at the force M2, the force F is providing the acceleration, while on M1, the normal is providing me the acceleration. Are you able to get me or not? But which acceleration? Since both of these blocks are moving with common acceleration, so I'll write both of these bodies have a common acceleration AC. Are you able to get me or not? Understood. So can I write that this normal is responsible for the mass M1 into acceleration AC or not? So what is that normal N1? M1 F by M1 plus M2. बोला है ना? So did you got the contact force? This is my normal. This is the pair of normal which is going to be called as a contact force between the blocks M1 and M2 or not. So N is equal to M1 F by M1 plus M2. Are you able to get me? Is this clear? Now, if I try to think of M2, what can be the equation? Means we'll write the equation of motion. So look over there. This F is trying to push the body M2, isn't it? But which force is oppose the motion? Correct. N is trying to oppose. So the pushing force minus opposing force is equal to my mass M2 and its common acceleration AC. So basically your equation of motion for M2 is this. Are you able to get me or not? Once again, when you will put the common acceleration AC value, you will see that normal is going to be still come as M1F by M1 plus M2, and that is my contact force between the blocks. Is that clear? Understood? मजा आया? ऐसा क्वेश्चन पहले बनाया था जल्दी जल्दी नहीं ना? चलो तो इसका एक और टिपिकल टाइप कंसिडर करते हैं. लेट अस कंसिडर वन मोर टाइप ऑफ दिस and then we will have much more different types of that. So consider this to be first block, in front of it a second block, okay, and there are this time three blocks. Consider it to be M1, M2 and M3 placed in front of each other. Are you able to get me or not? How many blocks are there? Three. And then once again I try to push them by an external force, F. M1, M2 and M3. Once again find the contact forces and equation of motion of each body. बताओ क्या होगा? Do it fast. 2 minutes you have. हम्म। बताओ जल्दी से। यार मेरी इंग्लिश ऐसे लगता है डगमगाई हुई है ना। थोड़ी बहुत इंग्लिश मेरी वीक लग रही है ना। यस। पता है तो जब मैंने एनआईटी में एडमिशन लिया था, ठीक है, तो आई वेंट टू द कॉलेज, ओके। सो आई थॉट when I when I went to the college, I thought let's, like, there were two professional courses which we were required to take. Okay, so I thought let's go into humanities department. Why? Because in humanities departments all the DU girls used to come over there. Go ahead or not? So I took the first professional course as humanities. I went over there, and you know what happened? The first class was a presentation class. So I went for presentation. I thought it will be easy. I'll rock it and all. I went over there and I said, instead of I am Anurag, I told, am I Anurag? Good or not? At that time, after that, I never ever went to that particular course. But still, I got excellent grades. That was that particular Anurag over there. So, ये बना question? You didn't got it? We'll tell the story next time. बताओ क्या होगा? Separate it first. The first task is to separate the blocks. Then, after that, first separate the blocks, then after that, so this is M1, M2, and M3. First of all, they will move with a common acceleration AC, isn't it? They will have a common acceleration of all three of them are moving by a same force, so force by total mass of the system M1 plus M2 plus M3. Are you able to get me or not? ठीक, अब ध्यान से देख। तो अगर M1 पे फोर्स लगाया, तो for this force there will be an normal reaction on M2, isn't it? I call it as N1. So there is an equal and opposite N1 on M1. Are you able to get me or not? Yes. Now, if I look over here as N1, now M2 is also trying to push M3. So there will be an normal on M3. I call it as N2. And there is an equal and opposite reaction. All of them are moving with common acceleration AC. Yes. So what is the equation of N1? So basically N2 means mass m3 into its common acceleration AC. Equation क्या आएगा? m3 common acceleration AC is how much? F by. Are you able to get me or not? Yes. Similarly, for m2, if I write m2, what will be the equation? N1 minus opposing force is N2 for M2 or not? So N1 minus N2 is equal to M2 into common acceleration AC. So equation will be N1 is equal to N2. N2 you got it, M3F by M1 plus M2 plus M3 plus M2 into common acceleration AC, which is F by M1 plus M2 plus M3. Are you able to get me or not? So the normal N1 is equal to how much? Sum of these two, M2 plus M3 into the external force F divided by M1 plus M2 plus M3. So this is my N2 and this is my N1, and these are the contact forces. N2 is the contact force between M2 and M3, N1 is the contact force between M1 and M2. Are you able to get me or not? Is that clear? Understood? And then I can write the force equation of M1. What can be that? F minus of N1 is equal to into acceleration AC. Common acceleration AC. Are you able to get me or not? Understood? Perfectly? Okay. So now let us do one more thing. Let us bring these blocks on the inclined plane now. Okay. So give the heading inclined planes. Now this is going to be little bit weird and tough, but still it is going to be amusing and easy. So consider an inclined plane. Inclined plane means a plane making angle theta with the horizontal. Are you able to get me or not? And then I place a block of mass m on it. Place a block of mass m on it. This is mass m on it. On it. Okay. So place a block of mass m on it. And then the question is, if the surfaces are smooth, then find the normal reaction and equation of motion. Mhm. You tell me the block will go where? Lost. How come it will go up if there is no external force? Yeah. So it will never ever go up. If it is required to go up, then it must have a external force in the upward direction. It will always go down, isn't it? Then draw the normals and the equation of motion. Write the equation of motion and the normal. Now you have to little bit think about it. If I look at the particular contact force, if I look at the contact surface, this is my contact surface, and a line perpendicular to it will represent the direction of normal or not. So this will be my direction of normal. Are you able to get me or not? Is that clear? Now, if I look at the particular M, then the weight of the block will work downwards, isn't it? Weight will be where? Downwards. I call it as equal to how much? mg. इसको क्या बोलूंगा मैं? mg. Are you able to get me or not? Now, if I look into this mg, think of one case. Is this angle is also going to be theta? Yes. Then draw this angle also. Yes. Draw this angle. So if this angle is theta, this angle is going to be 90 minus theta. Theta only. Are you able to get me or not? So looking at these things, you know that attached side is a cos component, isn't it? So mg along this side will be how much? Mg cos theta, and mg along the incline. One, I can resolve it along the incline or not. So this will be how much? Mg sine theta. Are you able to get me or not? So basically, what's the meaning of that? That normal is exactly as the body is not doing wobbling motion. So n is equal to how much? Mg cos theta. Is this clear? Now, if n is equal to mg cos theta, look at the another force. What happens with the mg sin theta? So there is no other force to balance this mg sin theta now. So this mg sin theta works like a F external down the incline. external force down the inclined plane. Are you able to get me or not? Yes. So down the inclined plane means what? F external, any force mg sine theta will try. So basically this mg sine theta will try to generate acceleration in this block M or not. So mg sine theta can be written as m into a. Yes. So m got cancelled and acceleration becomes how much? Are you able to get me or not? Look into this equation. This equation has a very useful insights. What are those? Look into this. That this equation is independent of mass. Independent of mass. Means acceleration on a smooth inclined plane is totally independent of my mass of the system. Are you able to get me or not? It's just depend upon this inclination theta or not. This acceleration independent of mass but depends upon what? Inclination theta. Are you able to get me or not? So what's the meaning of that? How to understand this in a perfect way? How to bring it in a conclusion? So ध्यान से देखो. So if I have, let's suppose I took an inclined plane. I took a perfect inclined plane, and then if there are many masses m1, m2, m3, and so on, if you look into all these masses, if this inclination is theta and if this surface is smooth in nature, which kind of nature? Smooth. Then all these blocks pose same acceleration. G sine theta, G sine theta, and how much? G sine theta. Are you able to get me or not? So if they pose all the same acceleration, the relative contact between them will be kind of a contactless force between them or not? Yes. So the relative contact between these all the blocks becomes how much? Zero. So contact force between them. Between them. Yes. Then only they will move with the same acceleration or not. Because everyone is moving by their own acceleration. Are you able to get me or not? No one is trying to push anyone. Is this clear? So the contact force between them becomes how much? Zero. But does the normal has become zero? No. For each and every, there is an normal with respect to the surface. This is n1, this is n2, and this is how much? N3. N1 is equal to m1g cos theta, n2 is equal to m2g cos theta, and n3 is equal to n3g cos theta. Are you able to get me or not? Understood? Totally? ठीक मैं आगे बढ़ू क्या? So basically, now we'll try to bring all of this conclusion with the perfect thing which we did to one day back, and that was the concept of inertial and non-inertial frame using these many vector equations and all those kind of things, isn't it? So those who are watching on YouTube, please follow lecture number 2 for inertial and non-inertial frames to understand upcoming things. Okay. So you can apply, or you can give the heading like inclined plane with pseudo forces. With pseudo forces. Are you able to get me? Okay. So let us think of an inclined plane. And I place a block of mass m over here once again. Tan, tada, tada, tada. No, one day I wanted means I asked God why you made me physicist. He told you know Anurag, you have the talent of each and everything. Means one time I asked God why you made me physicist. Okay. He told only one thing. You had a talent of each and everything. That's why I made you a physicist. He told me like dancing, singing each and everything, but you do not do anything. That's why I made you physicist. So this is my inclined plane. Okay, I placed a block of mass m on an wedge. Okay, and this wedge has a wells over here. Got it? Now this, if बोल रहा है कि if this wedge goes with an acceleration a naught towards right side, then find the equation of motion of m. Okay, and the normal reaction from the block, from the waves on the block. Tell me fast. Normal will be same. Is normal is going to be same? Think, think once again. Is normal is going to be same? Yes. One thing, there is a comment on YouTube like, does the position of application of force affect the force? Like if we applied the force on A's or on its center, uh, the thing is correct. Means he is asking that same thing, that application of force must be present on the center or something like that. The answer is correct because every force acts from the center of mass. So we have to consider that application of force from the center. But I told you that we are just taking as for our convenience, isn't it? Yeah. So we have written for our convenience, we select that it is present on the point of contact. ठीक है, बताओ जल्दी से क्या होना चाहिए? What should be the answer? Now look over here, देखो ध्यान से देखो, like what can be this? अच्छा एक बात बताओ, अभी तुमसे मैंने कुछ देर पहले बताया था कि लेट्स सपोज इफ आई प्लेस अ ब्लॉक ऑफ मास m over here and this wave is accelerating towards right with acceleration a naught or, so this wave is a inertial frame or non-inertial frame? This one is a non-inertial frame. So any particle on this will feel an pseudo force exactly in the opposite direction with the mass of the particle and acceleration of the frame or not. Yes, so m and naught will be present in the opposite direction, but the weight of the block will be vertically downwards. Are you able to get me or not? Yes, mg will be vertically downwards. So now look over here. If this is my mg, this is m and naught. So this particular direction, if you look at this theta, then this will be my mg cos theta. And you know that for an inclined plane, the normal is perpendicular to the incline. So this will be the direction of normal. So look into m and naught. So this is theta also over here or not? I think that is theta. If this is theta, then that is also going to be my theta. Are you able to get me or not? So basically, If this is theta, so m a naught will have two components, one towards this direction and one along the direction of normal, isn't it? Yes. So, so this is m a naught cos theta, while this is m a naught sin theta. Are you able to get me or not? So now mg will have one more component. We forgot one more component of mg. This mg will have one more component over here or not? That will be how much? Mg sin theta. Yes, two perpendicular components, isn't it? We resolved mg also. Why we got it on? So basically, this normal equation will be what? Normal. So if the bodies is stick to the surface, okay. If the body is in contact with the surface, so normal plus equal to, are you able to get me or not? So n is equal to how much? M common g cos theta minus a naught sin theta. Are you able to get me or not? And if I look into the mass equation, now if we look to the force, there is no force in the opposite direction, isn't it? If I look into the opposite direction, there is no force. Are you able to get me or not? So which two forces are pulling this block? These two forces. So basically, external forces are m a naught cos theta plus mg sin theta must be equal to my mass m into its acceleration a, which is towards where? Down the block. Are you able to get me or not? got cancelled, and a is nothing but a naught cos theta plus g sin theta. Are you able to get me or not? Is that clear? Understood? Okay. Now let us take all of these things. We can bring these many things. We'll talk about the talk of friction in the content of friction, word or not. But we are just talking without the friction each and every case. First, we talked about normal, then we'll talk about tension, then we'll talk about spring, and then once again the combined effect of all these in the frictional forces. Are you able to get me or not? Right. So we'll see one more case, and we call that case as a case of lift. You know that particularly. Lift cases. Okay, is that clear? So let us bring the lift cases over here and we'll try. See, there are three lift cases in the books, but we'll talk about four lift cases right now. Are you able to get me or not? Okay, so let us think. Let us bring first case of the lift. Let us consider that I place a block of mass m inside a lift. ठीक है? बोला कि एक ब्लॉक ऑफ मास m रख दिया लिफ्ट के अंदर, है ना? तो मान लो ये मास m है, ठीक है? और अभी ये जो लिफ्ट है वो एक्सेलरेशन a के साथ कहाँ जा रही है, a नॉट के साथ कहाँ जा रही है? नीचे। बोला कि फाइंड द, क्वेश्चन पूछ रहा है कि फाइंड द इफ द मींस, क्वेश्चन इज फाइंड द नॉर्मल रिएक्शन इन ऑफ द ब्लॉक। जल्दी से बताओ। तुमने वो नेट जियो वाली वो अल्बर्ट आइंस्टाइन की सीरीज देखी है क्या? हैव यू वॉच्ड इट? दैट अल्बर्ट आइंस्टाइन सीरीज ऑन नेट जियो? Yeah, it is not on Netflix. You can look on Chrome or you can download it. That's called, I think that's called Genius season, okay, of Albert Einstein. You have done this thought experiment in episode number 4, okay. That's an awesome thing. Actually, this concept of this normal, see, the normal was brought by Newton and all those kind of things, okay. But this concept of this pseudo forces was brought by Albert Einstein, basically. Are you able to get me or not? Okay. So he brought these all these equations. Now tell me, what is the normal reaction when the lift is going downwards and the block is kept inside the lift? Tell me. What can be that? Moves. Uh-huh. Really? You are again following. Read. Is G is going to be bigger or N naught is going to be bigger? So first case appears over here. N naught is less than G. Are you able to get me or not? So now when I look over here, the weight of the body is downwards. Normal will be upwards. But D अब एक बताओ ये lift कौन सा frame है? Inertial and non-inertial? Since a lift is an accelerating frame, so it is a non-inertial frame of reference. Are you able to get me or not? So the mass m will feel a pseudo force in the upward direction opposite to the direction of lift's acceleration, which will be mass into the lift acceleration m and naught. Now, as the body is sticked over there, then normal plus m and naught must be equal to how much? Mg. Equation you got as what? N is equal to mg minus a naught. Are you able to get me or not? Now think of a case when, consider the second case, when a naught is greater than g. What will happen? Lift. Consider a case when a naught is greater than g. Yes, this is my lift, and I place a block of mass m. Okay, and this lift is going still downwards with acceleration. Yes, what will happen? Is this block is going to fly or what? Of course. Why? Think of a case. See, the downward force is how much? Mg, and due to the acceleration of the lift, the pseudo force in the upward direction will be how much? M naught. But here m naught is greater than mg or not? Because a naught is greater than g. So it must fly. It must fly, and it will hit the top boundary or not. So then, what will be the normal? So it will hit the top boundary, and the body will come over here. Yes, mg is still downwards, but the upward force is how much? M naught. But the normal this time will be negative downward direction or not? Yes, the normal will be perpendicular to the surface from the rigid body towards the smaller object. Are you able to get me or not? Yes, it will bounce off. Are you able to get me? Yes. So now, when it is like that, then I can write the equation n plus mg this time is equal to m naught. Yes. So the n becomes how much? Can I write it as m a naught minus g? But what is this? I can take this as negative common, minus common, and this becomes m g minus a naught. Are you able to get me or not? So this is a negative normal. That's it. This is an example of which kind of normal? Are you able to get me? Negative normal suggest the usual case of normal is always from heavier body towards the lower mass body, but this normal will be present towards the downward direction. It will stick to the top, and it will stick to the top, isn't it? Until unless we consider other cases of the system. Okay. Yes, it will stick to the surface on the top of the lift. Are you able to get me or not? Which is very, very means this is a kind of crude example. We are not considering any kind of collision over here. Are you able to get me? Understood. So here the collision effect are ignored. Okay. Can I move ahead? Okay. So now look over here. Now let us consider this particular case. Okay. Now when the lift is there, and now once again I placed a block of mass m. Okay. And but this time this lift is going up with an acceleration how much? Then find the direction of normal and the value of normal. ये तो आसान है ना? And after completing this question, I'll ask one thing. G plus A naught, correct? So look over here. The mg is downwards and pseudo here does not matter at all because the lift is going upwards. Both the forces are in downward direction. So m will be always strict to the surface. Are you able to get me or not? Understood. But in the previous problem, there is a chance that since there is a pseudo force in upward direction, if it becomes more, it will try to fly off. Are you able to get me? Bounce back. So here the normal will be exactly equal to how much? Mg plus A naught. Are you able to get me? Now, why we are what is we are doing? Why we are calculating so many normals? Why are we? Okay, my English is bad. I told you already. I got breakups due to this. Yeah. Why are we calculating normals? The disasters of my life came through this particular thing. I didn't understood English. Okay, so the question is why are we calculating normals? Can you tell me? That's a good one, no? Yeah, that's what I ask usually. I asked at the end why we are calculating, why are we calculating normals? Any answers? So that's what you have to understand first. What are normals? We went through that, isn't it? We went through all these through to what are normals. No, we went through the numerical analysis of normals. So we got to know normal is a contact force. That's all we got to know, isn't it? But actually, what is normal? See that. Uh, let us think of one case. Let us think of one case that there is a lift and a person is standing over here in the lift on a weighing machine. Okay. And this lift is going first upwards. Okay. And then after that downwards with such an acceleration a naught which is less than g. Okay. Are you able to get me? Now when you see these two cases, let's suppose the mass of the person was m. And when the lift was stationary, he measured that his weight is how much? Mg. Are you able to get me or not? But when the lift goes up, what he found that this weight has increased, isn't it? When he went down, basically he found out that his weight has decreased, isn't it? So basically, what is normal? Normal is a measurement of weight or not. Are you able to get me? So nothing. Normal is nothing. Normal is a nothing force, but normal is something which is providing us a clear idea of weight of the body. And as you know that weight of the body is a variable quantity. Are you able to get me or not? So whenever you are measuring your weight, you are actually measuring your normal, not the weight. Are you able to get me or not? Let's suppose if I take a particular weighing machine and I measure on a rough ground, means let's suppose you went into your bedroom and your bedroom has a that particular mattress, big one mattress. When you measure on the ground, your weight will be something. When you measure on the top of your bed, your weight will be something. So what has decreased basically? The reaction force has decreased because if I stand on the particular bed, the bed will turn in this kind of surface or not. And for this kind of surface, as you know, the normal will get decreased. Are you able to get me or not? Because the body is not rigid. So what is normal? Normal is nothing but a reaction force which we are measuring, which we also call it as weight. So weight is mg definitely, but weight is measured through the normal. Are you able to get me or not? Understood? Yes. So why we are calculating normals? To find weight. Yes. That's a perfect meaning. You are going to improve my English. That's nice. Are you able to get me or not? Yes. So why normals has an answer? Why normals means the normals are nothing but the weight of the body. Is that clear or not? Understood? So basically, if we calculated the lift case, which was going downwards, normal has decreased. Here the normal has increased. That means weight has been increased. The question arises, when is the weight zero? There is a chance that weight can be also zero. When is the weight zero? Hmm? There is a chance, no? Weight has decreased, weight has increased, then when is the chance that weight to be zero? So basically, how to measure the weight? We are measuring the weight by normal or not? Yes. Who is this anonymous guy on YouTube? He's replying perfect answer. Okay. So when is the weight zero? So weight is a measure of normal, isn't it? So now you think of one case when the lift is going downwards, weight is always increasing. But when the lift is going downward, in one case, the lift, the particular normal is always decreasing or not? Is it? Now if think if I put a naught exactly equal to z, normal will be zero or not? So when the lift goes down, why not? Let's suppose do not do anything. Let us take the lift, the thread which it is attached with the rigid support, cut it. The lift will fall with gravity. Word or not? Yes. So when makes sense, sir? So when the particular a naught is equal to z for the lift going down, basically due to that normal becomes how much? Zero, and that means weight has become how much? Zero. Or the particle is, that's when we feel weightlessness. When is the condition of weightlessness? When normal becomes zero. Are you able to get me or not? Is that clear or not? So basically, you have to understand that these all are connected. If I say weightlessness, if, let's suppose if I jump from a building, okay, means I thought I do not have many money, I have went bankrupt and all. I jumped from Burj Khalifa, correct. Then that Dubai Sheikh came. Oh man, he jumped. Let us donate him 100 plates of gold, word or not. So I jumped from a building. So the net force on the block is still not zero. Is net force is zero? It's not zero. Why? Because the body is getting attracted towards the center. Why? Isn't it? Body is, isn't it? Body is getting attracted towards the center. Are you able to get me or not? Are you able to get me? So this particular the body will definitely have weight mg downwards. Are you able to get me or not? So the net force on person is still not zero. But if I look at the normal of the body, is it zero or not? There is no touch from the ground. So normal is how much? So that is why the person feels weightlessness over there when you jump from the building. But weightlessness does not mean that net force will be zero. Are you able to get me or not? Is not a mandatory condition. Are you able to get me? Yes. So weightlessness means net force to be zero. It's not a mandatory condition. The weightlessness means normal to be zero. I will not have any kind of contact. Are you able to get me or not? Is this perfect? Understood? Totally clear or not? So weightlessness means net force to be zero is not a mandatory condition, but the normal should be zero to fill weightlessness. So therefore, see, there is a particular case, there is a particular example. One of the best example. What is there? If you as you have studied circular motion, I'll this comes under gravity, but I'll tell you right now, all right? And that is the satellite motion. Which kind of motions? So this is, let's suppose, Earth. Okay. Now, if you look into the particular Earth satellites, International Space Station. Let's suppose this is my International Space Station. I'm on the International Space Station. I became astronaut by killing one of the astronauts, whether or not, and taking his place. Okay. Now, this satellite is in orbit. That means this satellite is feeling a force towards the center of Earth or not? Yes, but if I look into the particular satellite persons, they always feel zero gravity. Why is that case? Isn't it? See, simple thing. The Earth is attracting the satellite. The satellite is in the orbit, but the persons inside it feels weightlessness. Yeah, that is zero gravity. Weightlessness is something like that only, zero gravity. You are flying off. Okay, you can say basically weightlessness. Let us consider it to be, give a perfect name, weightlessness. The person inside it feels weightlessness. They float, isn't it? Basically they float over there or not. Yes, I'll tell you. In the case of, oh, there is a nice question, listen. In the case of free fall, will the net force on the body be zero? There is a nice question on YouTube, I'll tell you. 1 minute. Okay, so let us consider this first satellite case, then I'll come on your question. That if you look into the particular satellite, it is getting attracted, but the persons inside that floats over there or not. Why it happens? So basically, look over there. When the satellite is rotating, it has some kind of velocity v, isn't it? So that means due to that, it will generate a centrifugal force outside over here or not. Yes, due to this presence of centrifugal force, the net force on the satellite becomes how much? Zero. Net force becomes how much? Zero. And the bodies inside it also feels the net force to be equal to how much? Zero. So basically this force is getting balanced by mv square by r or not? It's not be, you can't say that net force to be zero. Basically this centrifugal force is a outward force which is appearing to balance this satellite. So what will happen? Any mass over here inside that satellite, due to the presence of this force and the presence of this mv square by r, what will happen? Due to this presence of velocity also, this mass m, since there is a force towards downward, the force towards the outward will try to balance this person over there in that particular satellites or not. And due to that, the part satellite persons starts to float. Are you able to get me? Is that clear or not? Understood? So in all of this, what we found that normal to be zero. So there is a good question that for free fall, will the net force will be zero? Will the net force be zero? You only tell me. If I am doing a free fall, what is the meaning of that? That I am falling under gravity. This mass m, if it is going to fall, then it will fall under gravity or not. So how come net force is zero? If it is doing a free fall, it is getting attracted towards the center of Earth. That means mg is acting over there or not. So free fall means, yeah, free fall means weightlessness, and that means normal to be zero. That does not mean that net force to be zero. Are you able to get me? Is this clear or not? So in two cases, weightlessness and free fall are two same examples, and for them, both of them, the normal is zero, net force is not zero. How come? If it is a free fall, how come it is not going to experience a force? You are only saying that it is a fall. Fall means what? You are falling under. Uh-huh. Yes. Are you able to get me or not? मजा आया? बहुत सारी चीजें अपन सीखे आज है कि नहीं? Are you able to get me or not? Yes. So let us do one more numerical based upon this, and the last numerical of the series of the normals. And let's suppose there is a lift, and in the lift there is an inclined plane of angle theta. I place a block of mass m over here. Okay, and this lift is, oh, okay. Let us first consider that lift to A is going with acceleration a naught in the upward direction. Yes. Then find the normal. Once again, find the normal and acceleration of block. Tell me. If I would be there, I'll just think of one direct case. You found the normal? Uh-huh. Eh? Correct. Kind of correct. Yes. Okay, now look over here. So if I look into the mass, then this weight of the body is still downwards, isn't it? But with that, but with that, there will be one more force over here. The pseudo force. Am I not? Are you able to get me or not? Is that clear? Now, basically, I can write this as what? M G plus how much? You know, are you able to get me or not? Now, if I look over here, if I look over here, then along this side, that is M A G plus A naught cos theta. Are you able to get me or not? And similarly, along the direction of this side, what will be that? G plus A naught sin theta. Are you able to get me or not? So so this will balance with the norm. So n is equal to how much? M G plus A naught cos theta. Are you able to get me or not? Is this clear? Now, if I look over here, if I know this, then I also know this one more fact. This is my normal. Then what force? Now, if we look into the mass, this is my external force acting over here or not? And that external force is trying to accelerate my block. So M A G plus A naught sine theta is equal to how much? M A effective. Yes, cancel. And what is my effective acceleration down the inclined plane? Once again, this is independent of mass, but dependent upon lift's velocity. So G plus A naught Sine theta. Are you able to get me or not? And even consider the particular case of downward acceleration of lift. Are you able to get me or not? Yes. Now let's come to one of the last theoretical question and one of the best question which I was waiting to discuss right now. Why, how does moon rotates around Earth? Options are A. Net force on moon is zero on moon by sun weight and other planets is zero. Option B. Net force on moon, sorry, is zero because of sun and earth effect. Option C. Option C. The Due to the particular free fall of the moon motion. And option D. Due to uh, due to the effect of gravity of earth and sun on moon. Effect of earth, gravity of and moon. Tell me which option is correct. Tell me which one is correct. Is it D? Is it D? Dog, yeah. So is it dog really? How is net force zero? Of course, net force will never ever be. Okay, so first important conclusion, Earth and in the orbit is our moon, isn't it? So first important thing, as it is in orbit, net force is never ever zero. Force of gravity is trying to pull the particular moon towards the Earth, isn't it? But one thing is there, the force of gravity by the Earth also is the same on the moon. Both of these forces are same or not? Is it? Isn't it? Then what brings the moon in this particular motion? What brings it? Nothing, sir. It's this moon, this moon, as due to the force of gravity, tries to fall on Earth. What it is doing? Fall on Earth. Are you able to get me or not? Yes, remember that there is an anonymous message that how the forces are equal. Remember that force of gravity are always equal and opposite or not between two bodies. Yes. So now the moon is basically falling on the earth or not due to the force of gravity. Are you able to get me? But its tangential velocity over here brings an centrifugal force, which basically this tangential do not bring the concept of centrifugal force. This tangential velocity turns this moon and brings it over here. Are you able to get me or not? Yes. Now, once again from here, it will get attracted, but the tangential velocity means it will once again fall towards the earth, but once again its tangential velocity will bring over here, and once again it will bring over here. Why it will not get called towards the, if you drop if you take a ball, a simple, if you take a ball, okay, and drop it from the building, what happens? Does the ball falls towards the center? So if it is in the if it is in the field of gravity, ध्यान से देखो, अगर मान लो ये अर्थ है, ठीक, ये मून है, तो ध्यान से देखूं तो जो, अगर मान लो इसकी मास m1 है, इसकी मास कितनी है m2, इनके बीच की डिस्टेंस कितनी है r, तो बेसिकली जो ये जो इधर की ओर फोर्स लग रहा है मींस द बेसिकली द अर्थ इज ट्राइंग टू पुल द मून बाय फोर्स F इज इक्वल टू G m1 m2 by r square. So here is the product of masses, isn't it? It does not depend upon single mass. So this also is how much F is equal to G m1 m2 by r square. Are you able to get me or not? Yes. Now, the basically as Earth is kind of a stationary on its orbit. For the Moon case, we'll consider it to be stationary, isn't it? Yes. So for the Moon, as Earth is stationary, what will happen with the Moon? Moon will try to fall towards the Earth or what? Due to the force of gravity. Are you able to get me? Remember, every time gravity depends upon the product of masses. This force of gravity is directly proportional to m1 into m2, not on m1 and m2. Are you able to get me or not? So basically, what will happen? The moon will try to fall towards the earth, and as it is falling towards the earth, what will happen? Its tangential velocity will bring back over here. Then once again, it will be bring back over here. Then once again, it will be bring back over here. Are you able to get me or not? So what makes the moon rotates? It's its free fall, not the effect of gravity. Are you able to get me or not? Makes sense, makes the perfect sense, not the sense, makes the perfect sense. Are you able to? Same thing. Every planet is under the free fall towards the sun. Every satellite is on the free fall towards the earth, but their tangential velocity makes them stationary on their orbit. Understood? Is that correct? I'll clear one doubt of one YouTube guy if you are also interested. Should I discuss? Simple. They are asking that difference of masses does not affect gravity. Remember, if this is m1 and this is m2, then force of gravity says that F is equal to G m1 m2 by r square. This means that this force is independent of single mass and this mass. It is dependent upon product of masses. So if I say if m1 is heavier, m2 is of lesser mass, it does not affect anything. M1 will be attracted by same force, G m1 m2 by r square, and m2 will be also attracted by same force, G m1 m2 by. Is that clear or not? Are you able to get me? Chalo. So this was all about normals and all. We discussed many things regarding normals. Then tomorrow we'll discuss about tension. Are you able to get me or not? It, so we put, okay, we'll put one class tomorrow. Okay, we'll put one class. You have any kind of work or any kind of thing? After what time you are? After what? Till 9 p.m. Okay, so I'll take the class by evening 6 p.m. Is that okay? Uh, okay, so I'll take the class at 7 p.m. That will be perfect for you, isn't it? Okay, 6:30. Is that perfect? Afternoon, I have the class. I have the classes. In the okay, let's we'll see that. I'll inform the class tomorrow. I'll schedule the stream on based on that basis. Okay. Okay. I'll just put the class whenever you tell me, and based upon that, I'll stream the session. Okay. Okay.